Gravity explained with Minecraft. Let's go. But first of all, two great minds changed how we understand the universe, Isaac Newton and Albert Einstein. But before we talk about Einstein, let's travel back in time to around 1666 in the mid-17th century. To do that, we'll build our time machine to travel with Newton. Alright, we've got our time machine, let's go. We'll turn it on, let's go, let's go, let's go. We've arrived. One day Newton was sitting under a tree when suddenly, boom, an apple falls to the ground, and he asks himself, why does this apple go down and not up? Or if it goes straight, what makes it fall? Newton didn't remain in doubt, so he began to investigate.
Hi.
Newton, what are you doing?
I just formulated a theory which deals with an invisible force that we cannot see, but that is here.
From that point, Newton went beyond what his peers imagined.
May realized esoterico lequamasi anasopretasus. There's an invisible force acting on all objects, attracting each other. The larger the object, the greater the force with which it will attract smaller ones, like us with Earth, which is what keeps us on the ground.
But Newton didn't stop there.
What if that same force also acts on a larger scale, like on the moon or planets?
Newton started to connect the apple's fall with the movements in space.
What if that same force that makes the apple fall also keeps the moon orbiting around the Earth?
After much analysis and calculation, he concluded a force attracts all objects with mass. That force is what we now know as gravity. Newton wrote this idea in a very simple yet powerful mathematical equation, where F is the gravitational force, G is the gravitational constant, something Newton included but didn't precisely calculate in his time. O sea, M1 and M2 are the masses of the objects that attract each other, and R is the distance between their centers. But it didn't stop there, as centuries later Albert Einstein would arrive. Now it's time to change the century. Let's go to our time machine to Einstein's era.
Something feels off. I need to improve this theory.
So, point at the beginning of the 20th century, Newton's physics was changing. Though his idea of gravity as an invisible force had worked for centuries, as it couldn't explain all phenomena, such as the irregular orbits of Mercury, or what occurred near massive objects like stars and black holes. Einstein, with his incredible capacity to imagine concepts, reapproached the problem from the ground up. In 1915, he presented his theory of general relativity. Gave us a whole new view of how gravity works. Let's talk to Einstein so he can explain more. Hi Einstein, what will you teach us about gravity today?
Well, I discovered that gravity is not a force, but a distortion in space-time.
But what is that about space-time?
That space and time are one. Well, I'm going to explain it in more detail. Imagine space as a stretched sheet. If you place a bowling ball in the center, our sheet sinks. But that's what happens with space-time according to my theory. Very heavy objects, like stars and planets, cause space-time to curve.
So then, what about the planets revolving around the sun?
So, it's like marbles rolling on a curved sheet. No mysterious force pushes them. They simply follow the easiest path, dictated by space-time's curvature. That was my explanation. Back to you.
Yum, 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 yum.
Thank you very much Einstein for explaining to us, but I also wanted to tell you about an amazing experiment. In 1999, during a solar eclipse, scientists observed something incredible. The stars near the sun seemed to move from their usual position, but why? Because the light from those stars had to pass near the sun, and because the sun is gigantic, it curves space-time around it, causing the light passing through to bend. That's what's called a gravitational lens. This experiment not only confirmed Einstein's theory, but also changed our view of the universe. Shout out to these people. If you liked the video, please subscribe. Here on the right, a video on how to stop procrastinating. On the left, the relativity video. If you're watching this after it's up, or if not, a video you might like. Thanks for watching, and comment taco.